All right, we're going to talk now about how to find the inverse algebraically. So the notation for the inverse of a function is f to the negative 1 or f of negative 1. And this literally means the inverse of the function of x. So you're going to see this notation a lot. It just means find the inverse. So just as you switch the points xy to yx for graphing an inverse, we're going to switch the x and y in our equation, and that's how we're going to find the inverse. So step one, we're going to set f of x equal to y, okay? So we're going to say y equals 1/2 x minus 5. We're going to replace the f of x. Step two, we're going to switch the x and y. So we're going to get that x is equal to 1/2 y minus 5. And now your final steps are just to solve it for y. So we're going to add 5 to both sides, and I'm going to get x plus 5 is equal to 1/2 at y. And how are we going to get rid of half of y? That's the same thing as multiplication. So we're going to multiply both sides by a 2. And that's going to get rid of that. And now we've got y is equal to 2 times x plus 5. Well, you're going to be asked to distribute that because we're going to want to graph it. So 2x plus 10 is the better way to write that. Now, I normally have a 10 by 10 grid, so it's going to be a little bit more interesting to graph these. The first one we can graph easily. Y equals 1/2 x minus 5. We go down to negative 5, and then we're just going to go up 1 and over 2. And we're going to connect those with a nice line. But for a purple one, we're going to have to use our imaginations. Here's 7, 8, 9, 10. I'm going to go down 2 and over 1, and then I'm going to go down 2 and over 1. So now I kind of come onto the graph. And there we are. Get that graphed. Now, if you look at them, again, remember, we're looking to make a reflection over this line, and it is a perfect mirror image, okay? They are inverses of each other. They should look like that. So what happens when we get something a little more complicated? Well, it's not going to be that awful to do this. Now, if you remember, this is just a parabola that's been shifted 2 to the left, okay? So we're going to just start graphing that, and I'm going to cheat my way through it by just graphing a regular parabola like this, out 2 and up 4. And I'm just going to grab it and shift it 2 to the left. So I'm just going to go copy it, scooch it over 2 to the left, and there it is. Just in the interest of time. Now, let's start by switching x and y. So we're going to say that x equals y plus 2 squared. We need to get that y all by itself, and so we're going to need to undo this squared button, and the way to undo a squared is to take a square root. Now remember, when you take a square root yourself, you drew it in, it wasn't already there, we need to put the plus and minus. We need to account for both possible solutions. So now this cancels that out, and we're going to get that this plus or minus the square root of x is going to equal y plus 2. Well, this part is the easy part. We're just going to subtract 2 now from both sides, and we're going to get then that y is equal to, you can write it with the negative 2 in front, or you can still write plus or minus square root of x minus 2. Well, we know that a square root function looks like a little hook like that. But the reason we need the plus and the minus is because we're going to need the bottom part of the hook too, so that it looks like it belongs with that parabola. So let's graph this. And we'll do this one with a little table sort of. Remember, we want to make good-looking square roots like 0, square root of 1, square root of 4, and square root of 9. So we're going to plug in those numbers. So the square root, if we plug in x is 0, we're going to get that 0 minus 2, which is negative 2. And I keep getting scrolled up to the top. Sorry, girls. So we're going to graph that. Then we have what happens when you have 1. Well, we're going to have a few little things. So I'm spacing this out. When you have 1, we're going to get two possibilities. We're going to get the plus square root of 1 minus 2, and we're going to get the minus square root of 1. So it's minus 1 minus 2. So we're going to get negative 1, and we're going to get negative 3. Ugh. And so let's get those graphed. So when x is 1, we're going to get negative 1, and we're going to get negative 3. And we're going to try 4. When we plug in the square root of 4, we're going to get the positive version. So the square root of 4 is 2 minus 2. And we're going to get the minus version. So we're going to get 2 minus 2. So we're going to get 0, and we're going to get negative 4. I am so sorry. 0 and negative 4 right down here. And now if we connect these with a curve, you can see they are inverses. So there's one last example I want to show you so that you don't panic when you're doing something as easy as a line. So if we scooch down and we just try this one problem right here, we're going to change f of x to y. We're going to have them switch spots. So x is going to equal 4y minus 9. We're going to add 9 to both sides. So we're going to get x plus 9 is equal to 4y. And then finally, we're going to divide both sides by 4. Well, this is not an okay way to write the equation of a line. So I'm going to make them both over 4 like that. And technically, this part here would just be the same thing as saying 1/4 x. So we have 1/4 x plus 9/4. Sick. No one wants to graph that. So what I would do, instead of using that y-intercept, if they asked you to graph the inverse and the original function, I would steal the points from this and just switch the x and y and graph it that way because it would be a lot easier.